In this video, we're going to talk about symmetry. Now, I think the best way to understand symmetry is to just see some examples rather than going through a bunch of definitions. So notice, first of all, we have a graph here that is symmetric with respect to the y-axis. So what does it mean to say that this graph is symmetric with respect to the y-axis? It means that the graph is a mirror image of itself across the y-axis. So in other words, if we were to flip this function around the y-axis, we'd end up with the exact same function again. Okay, so it's symmetric around the y-axis, or with respect to the y-axis. Now there's also symmetry with respect to the x-axis. Now this would not be a function here, right? It doesn't pass the vertical line test, but this graph is, if I've drawn it correctly here, symmetric with respect to the x-axis. It's a mirror image of itself across the x-axis. Okay, now there's one other type of symmetry with graphs called symmetry with respect to the origin. And what symmetry with respect to the origin means is that if you take this graph and you flip it across the y-axis, okay, so then you'd end up with a graph that looks kind of like this. And then if you flipped it again across the x-axis, you would end up with your original graph again. Okay, so if you take your graph and you flip it across the y-axis and then flip it upside down across the x-axis, and if you end up with the same graph as your original one, then we say it's symmetric with respect to the origin. So this graph is symmetric with respect to the origin. So let's look at a couple of examples. Is the graph symmetric with respect to the x-axis, the y-axis, and the origin? So notice, is this graph symmetric with respect to the x-axis? If we flip it upside down, right across the x-axis, do we get the same graph? No. Okay, but if we flip it across the y-axis, though, we will get the same graph. Okay, so it is symmetric with respect to the y-axis. Now what about symmetric with respect to the origin? If we flip it across the y-axis, then flip it upside down across the x-axis, do we get the same graph again? No. Okay, so it's symmetric with respect to the y-axis, but not the x-axis or the origin. Okay, let's look at another graph. Is this graph symmetric with respect to the x-axis? No, if we flip it across the x-axis, we don't get the same original graph. Is it symmetric with respect to the y-axis? No. If we flip it across the y-axis, the graph's going to look different. And same thing with the origin. If we flip it across the y-axis and across the x-axis, we're not going to end up with our same original function. So here's a graph that's not symmetric with respect to the x-axis, y-axis, or the origin. Okay, and lots of graphs are like that. They don't have any type of symmetry properties. Okay, now is this graph symmetric with respect to the x-axis? Now what I've drawn here is a circle. I didn't draw my circle very well, but let's assume this is a perfect circle here. Is this symmetric with respect to the x-axis? If we flip it upside down, do we get the same original graph? Yes. Okay, is it symmetric with respect to the y-axis? If we flip it across the y-axis, do we get the same original graph? Yes. And what about if we flip it across the y-axis, then across the x-axis, do we get the same original graph? The answer is yes. This is symmetric with respect to all three. Now, if I made the circle up here, then that would not be symmetric with respect to any of those things, with respect to the y-axis, x-axis, or the origin. So it matters how it's positioned. Okay, now we can also talk about symmetry of a point with respect to the x-axis, the y-axis, or the origin. So let's do an example. Find the point that is symmetric with respect to 5, 2, or find the point that is symmetric to the point 5, 2 with respect to the x-axis. So we're taking our point 5, 2. We want to find the point that's symmetric with respect to the x-axis. Okay, so notice the point that if we flip this across the x-axis, what are the coordinates of this point? Notice it's 5 minus 2. Okay, so this would be 5 minus 2. Okay, what about if we take our original point 5, 2 and flip it across the y-axis? What point will we be at? We'll be at over here. This will be minus 5, 2. Okay, so when you're doing symmetry with respect to the y-axis, essentially what you do is you flip the x-coordinate and you change the sign of the x-coordinate. When you're trying to find symmetry with respect to the x-axis, you change the y-coordinate. You change the sign of it from positive to negative, or negative to positive, wherever the case might be. Okay, so remember this 5, 2 is our original point. Now what about symmetry with respect to the origin? Well, if we flip this across the y-axis, we end up with here. Then flip it across the x-axis, we're going to end up down here. Okay, so this is minus 5 minus 2. Okay, that's the point that is symmetric with respect to our original point. Remember, this is our original point with respect to the origin. Okay, let's do one more example. Find the point that is symmetric with respect to the point 3 minus 1, so that's what we've drawn here, with respect to the x-axis. So if we flip this point across the x-axis, notice that what we get is, instead of 3 minus 1, we get 3 positive 1. Right? We've changed the y-coordinate. Okay, if we take our original point 3 minus 1 and flip it across the y-axis, then we get this point here, which would be minus 3 minus 1. Okay, so that's the point that is symmetric to the original point 3 minus 1 with respect to the y-axis. Okay, and what if we take our original point and flip it across the y-axis, then flip it across the x-axis, and notice we'll end up with this point. This would be minus 3 positive 1. So notice that if you begin with a certain point and you're trying to find the point that is symmetric to that point with respect to the x-axis, you always just change the sign of the second coordinate, right? We had 3 minus 1, this flipped to 3, 1. Okay, and if you're trying to find the point that is symmetric to this point with respect to the y-axis, what you end up doing is you take your original point and you change the sign of the x-coordinate. So instead of getting 3 minus 1, you get minus 3 minus 1. And if you want to find the point that's symmetric with respect to this point, with respect to the origin, what you do is you take your coordinates and you change both of the signs. So instead of 3 minus 1, we end up with minus 3 positive 1.